Greetings the viewers. My name is Paddington. So today we'll be doing mathematics grade 11, chapter 1, exponents and sets. So this serves as a revision to those who are in grade 12 and also serves as a lesson to those who are in grade 11. So let's start chapter 1, exponents and sets. Let's see. So in grade 11 we are introduced to exponential laws. Like this one, number 1, we have a to the power of m. The dot means multiplication, so it's going to be a to the power of m multiplied by a to the power of n, right? So whenever we are multiplying, and if our bases, can you see the a and the a over there are the same, what do we do to the exponents? We add the exponent, so it's going to be m plus n, because the bases are the same, which is why it is equals to a to the exponent m plus n. So this is the example. Can you see the exponents are the same? We have 3 here, we have 3 here. So what do we do when you are multiplying? We add the exponent, so it's going to be 3 plus 4, which is 7. Then the second law, we have a to the power of m divided by a to the power of n. So if we have this kind of law, what do we do? Whenever we are dividing, we subtract the exponent. So which is why we're going to say m minus n. So since the bases are the same, we're going to say equals to a m minus n. Check the example. We have the example here, which is 2 to the power of 8 to the power of 8 divided by 2 to the power of 4. Since our bases are the same, what do we do to the exponents? We subtract the exponents. So it's going to be 8 minus 4. So it's going to be equals to 2 to the exponent 8 minus 4 equals to, so if we say 8 minus 4 is 4, so it's going to be equals to 2 to the exponent 4. Then from there, we get our 16 as the answer. So if it is 2 to the power of 4, it means we are going to write 4 2's like this. It is 2 to the power of 4. It means it's going to be 2 times 2 times 2 times 2. So it means we're going to write it 2 4 times. 1 2 3 4. Then if we multiply them, we get 16. Then 3, we have another law which says open bracket a to the power of m close bracket n. So here, when we have the brackets like this, it means multiplication. So it's equals to a, so we're going to say m times n. So it's going to be a to the exponent m multiplied by n, which is also equals to, so here they actually switched. So we can actually switch the m and the n. The m can be outside and the n can be inside. So it is still the same. There's nothing that has changed here. Let's see the example. So like I said, whenever we have the bracket, it means we are multiplying. So what are we multiplying? We're multiplying the exponents. So it's going to be 3 times 4. So it's going to be open. So we are going to remove the brackets, right? So it's going to be equals to 3 to the exponents 3 times 4. Then if we say 3 times 4, we get 12 like this. So it's going to be 3 to the power of 12, right? So as I've said, that can you see that here we have 3 inside, then we've got 4 outside. So we can actually switch. Check here. Now we have 4 and outside it is 3. So these things, it is the same. We did not change anything. Then 4, we have another law, which is open bracket AB. So remember, if there is no anything as the exponent on a and on b, it means there is 1, but that 1, it is invisible. So we can actually write 1 like this and 1 like that. And as I've said, whenever there is a bracket, it means we are multiplying. So let's see. So we're gonna write our base, which is a. Then say, remember I said on a there is an invisible 1, so it's gonna be 1 times m. So 1 times m is gonna be m. Then on b there's also an invisible 1, it's gonna be 1 times m. So it's gonna be b to the power of m, like this. Let's check the example. So we have the example here. So can you see on 3 there is no exponent. So so what we're gonna say, we say there is an invisible 1 like this. So it's gonna be at 3 the exponent 1 times 2 like this. Then the dot, it means multiplication. So it's gonna be x to the power of 4. Then this 4 times 2, so it's gonna be multiplied by x to the power of 4 times 2. Then on 3 there's an exponent, so it's gonna be like 3 times 2. So it's gonna be times y 3 times 2 like this. Then from there we simplify. So remember 1 times 2 as the exponent, it is 2. Then 3 squared, which is 9. Then it's gonna be x to the power of 4 times 2, 4 times 2, which is 8. Then the base, which is our x, is gonna be x to the power of 8. Then we have y, which is 3 times 2, so it's gonna be y to the power of 6. Remember 3 times 2, which is 6, right? Then we have law number 5, which is open bracket a over b, the exponent m. So here, as I've said before, that as on a there's no n exponent, so it's gonna be, also we're gonna write 1. Then on b there's no n exponent, we're gonna write another 1 as well, like that. So it means that the m is multiplying both a and b. So it's gonna be 1 times m is gonna be a to the power of m divided by 1 times m, again is gonna be a to the power of m divided by a b to the power of m. So this is the example. Let's check the example. So remember on 4 there's no exponent, so we assume that there's 1. So on x there's already an exponent, so we're not going to write 1. So here we're gonna say 1 times 3, which is which we're going to say for the exponent 1 times 3. Then we're gonna apply this 2 and 3, so it's gonna be 2 times 3, right? So it's gonna be x to the power of 2 times 3. So 1, so we know that 1 times 3 is gonna be 4 the power of 3 all over x, which is 2 times 3, which is 6. So from here they now have to simplify to get 64. How did they do it? Here is what they did. As I said before, that 4 the power of 3, it means we have 3 4s. So it means it's gonna be 4 times 4 times 4 3 times. So it means we're going to write 4 3 times. So 4 times 4, which is 16, then 16 by 4, which is 64. This is how they get 64 over x to the power of 6. So let's check exponential definitions. Number 1. So whenever there is a 0, whenever we've got a 0, 8 to the power of 0, it is 1. Even if you have 8, even if you have let's say 32, the exponent 0, the answer will always be 1. It does not change. Okay, then so these are exponential definitions. Number 2, we have 1 to the power of a, it does not change. Even if we have 1 to the, let's say even if we have 1 to the power of 320, the answer will still be 1. Because if we write 1 times 1, even if we write 1 320 times, we are going to get 1. It does not change. So 3, we have x. So this was the example whereby they said 1 to the exponent 2008, the answer will still be 1. It does not change. Then 3, we have x to the exponent negative n. So guys, exponents are always positive. So whenever you see a negative exponent, we try to make them positive, which is why they had to say it's equals to 1 over x to the power of n. So remember law number 3, it says x to the exponent negative n like this is equals to, so remember, which is also equals to x and negative n over 1. So this is how it is. So we can actually divide it by 1 like this, which is also equals to, so when we take this x to the exponent negative n down here, it loses the negative to be positive. So remember, if we take this x then with the exponent negative 1, if we take it to 1 on the, if we take it down on the denominator, so it's going to be x to the exponent n. What is left on top is 1. So this is how they got this 1 over x to the power x to the exponent n. So this is the example like this. So the exponents are always positive. So for that exponent to be positive, it means it has to be a denominator, then on top becomes 1. Then 5, we have open bracket x, open bracket ax to the exponent negative n like that. So as I've said before, the bracket, it means multiplication. So it's gonna be ax and negative is ax negative n like this, right? And as I've said before, that we are going to divide by 1 like this equals to. So if this open bracket ax close bracket negative n goes on the denominator, it loses the negative to be positive. So it's gonna be 1 over ax to the exponent n. So we can actually remove the brackets, and it will be like 1 over a to the power of n x to the power of n like this. So we can actually write it in this form or that form, but then it is best that we write it into this form, since the exponents are the same like this. So we continue. We are on we're doing definition 6. So if I have said that exponents, we have to exponents are always positive. So what we are doing here, we are trying to make all the negative exponents to be positive. So whenever we see a negative exponent, we change it into a positive exponent. So check number 6 here. We have 1 over x negative n. Can you see that the exponent, we have x to the exponent negative n, the exponent is negative. So we try to make the exponent to be positive, which is why we're going to take this exponent on top there to be on the numerator. So if it goes on the numerator, it becomes a positive exponent. So it is like this. We have 1 over x negative n is equals to, so if we take this one to be on top here, it loses the negative, becomes positive. So it's going to be x to the exponent n. So it is no longer a negative exponent, but it is now a positive exponent like that. Then we go to number definition 7. Still we are doing the same thing. Check here, our exponent is negative, so we are going to take this exponent to the numerator. So if we take the exponent to the numerator, it loses the negative to be a positive exponent. So this is the example. I'm going to take this on top there. If it was negative, becomes positive. So it's going to be 3 multiplied by x to the power of 4. Number 8, check here, the a, it is positive, but that x to the exponent negative n, it is negative. So we're going to leave the a behind and take this one to the numerator. So it was negative, so as it goes to the numerator, it loses the negative to be x to the exponent n. This is the example. 1 over 3, the 3 is positive. Can you see? Remember we said if a number does not have an exponent, we assume that it has a positive 1, and that positive 1, it is positive. Can you see? But then x to the power of negative 4, it is negative. That's why you have to take this negative x to the power to the exponent negative 1 on the numerator. So as we take it to as it gets on the numerator, it becomes positive, which is why the 3 has to remain, and the 4 becomes on the numerator. So it loses the negative when it becomes on the numerator. Then definition 9, still check. We said here, whenever we have the brackets, we are multiplying, right? So, and then still our exponent is negative, we are going to try to make it positive. So as it gets on the numerator, it loses the negative and becomes positive. The example 1 over 3, the example 1 over open bracket 3x to the exponent negative 4 is equals to so as it goes to the numerator again, it loses the negative and it becomes 4, which is why it is like this. Then 10, we have open bracket a over b to the exponent negative 1, like this, to the exponent negative 1, so equals to. So if we have something like this, what we do, it is very easy. We're gonna switch the a and the b. So if a was on the, like, can you see a is on the numerator, then b is on the denominator. So what we do, we are going to switch them. The a becomes on the denominator and the b becomes on the numerator. So immediately when we switch, the exponent becomes positive automatically. Check the example, we have like 3 and a 4 here. So if the 4 becomes on the numerator and the 3 becomes on the denominator, what happens is that the negative becomes positive, since we switched this value 3 and 4. And then 11, lastly, which is 11, we have a to the power of negative m, b to the exponent negative m. And as I've said, that we are always trying to make the exponents positive. So this a to the exponent negative m, can you see the exponent is negative, and the b here, it has a negative exponent. So we are going to try to make them positive. Check. So we have a negative m all over b negative n, like this. So what we are going to do, we are going to take this a down there on the denominator, so it's going to be a to the power of m. So as this gets on the denominator, it loses the value and becomes what? Positive. Check. This one on the denominator was negative, but as it goes up there like this, b to the power of n, it becomes what? Positive. So it loses the negative and becomes positive. This is how we do it. The example, so it's like we are switching here, because since this one is negative and that one is negative, this one, the one, so the x, this one, the x to the negative 3, the x exponent negative 3 goes down, the y exponent negative 4 goes up there, like this. So this is the example. We're going to take this x exponent 3 down, then y exponent negative 4 on the denominator, like this. So these are the laws of exponents. We are going to apply them as we'll be doing mathematics grade 11, and also we are going to apply these laws in grade 12 as well. So our lessons ends here. Please subscribe as well.